Now very clearly galvanometer and S are in parallel. So this is 96. So on simplification, 10 ohm is the answer. What is the magnitude of magnetic force? Newton per meter. How is that? Force is Newton. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In my today's session, I will work out a few problems from the NCERT textbook on the chapter Moving Charges and Magnetism. This being the last session of this chapter, hope all of you have practiced the session well, solved the previous problems, and with all enthusiasms and gaze have come to attend today's class. Let us start solving today's problems. So the first one, this is also one of the entrance problems. The problem says the deflection in a moving coil galvanometer. So the deflection in a moving coil galvanometer is reduced to half. Very important information. Is reduced to half when it is shunted with a 40 ohm coil. One moving coil galvanometer ide. Deflection in the MCG is reduced to half. The deflection in the galvanometer becomes half of the initial value when it is shunted with a 40 ohm coil. Shunted andre eno? When a 40 ohm coil is connected in parallel with it. What is the resistance of the galvanometer? Now, going back to the principle of the galvanometer, so all of us have studied that the current flowing through the galvanometer is directly proportional to the deflections produced in it. So in the chapter, we study that I is directly proportional to theta. The deflection is directly proportional to the current flowing through the galvanometer, which means since the deflection is reduced to half, Ig by I is equal to half. Current flowing through the galvanometer to the main current is reduced to half. Now very clearly galvanometer and S are in parallel, alva, shunted across the galvanometer. So potential difference across G should be equal to potential difference across S. Why? They are connected in parallel. Potential should be the same. Potential difference across G, I into G equals I minus, yes, IG into S. If you study the conversion of galvanometer to ammeter, you come across these expressions. Or, so this is IG, G plus S is equal to I. So, G plus S is equal to I by IG. But we know IG by I is nothing but, yeah, we have an S here. So, G plus S is IS by IG. So, G is required here. So, on simplification, we have IG by I is equal to S divided by G plus S. Now, substitute. IG by I is half, S is 40, G has to be calculated. So, if I observe again G plus S, G plus 40, so on simplification, G is 40 ohms. So, simplifying, the resistance of the galvanometer is 40 ohms. Next one. Again an entrance problem. The problem says, a galvanometer of resistance 240 ohms. The resistance of the galvanometer is 240 ohms, allows only 4% of the main current. Only 4% of the main current after connecting a shunt resistance. What is the value of shunt resistance? So, here the current flowing through the galvanometer is 4% of the main current. So, IG is 4 by 100 of I, or I will be 100 by 4 times IG, and G is given to be 240 ohms. Now I have to calculate the shunt resistance for this to happen. So we know shunt resistance is IG into G divided by I minus IG. where this is equal to Ig into G. So I is 100 by 4 times Ig minus Ig. So Ig gets cancelled. So this is 4 into G, 240. So 100 minus 4. So this is equal to, 4 into 240. 100 minus 4 is 96. So this is equal to 10 ohms. So see, current flowing through the galvanometer is 4%. 4 by 100 times the main current. So the main current will be the other way, alva, I, reciprocal. 4 by 100 becomes 100 by 4 Ig. We know the expression for shunt resistance. We know S equals Ig into G divided by I minus Ig. Ig into G. I is 100 by 4 Ig minus Ig. Ig gets cancelled. So this 4 goes to the numerator. 4 into G. G is 240. 100 minus 4 after LCM. So this is 96. So on simplification, 10 ohm is the answer. The next one. What is the magnitude of the magnetic force? Magnitude of the magnetic force per unit length of a wire. Per unit length of a wire carrying a current of 8 ampere, making an angle of 30 degrees with the direction of a uniform magnetic field of strength 0.15 Tesla. What is the magnitude of magnetic force per unit length? So length is 1 meter per unit length of a wire. Now it is not a charged particle. It's a charged conductor wire carrying a current of 8 ampere. A current of, so current is given to be 8 ampere. Making an angle of 30 degrees with a magnetic field of strength 1.5 Tesla. So this is a concept of magnetic force acting on a charged conductor, not a charged particle. So what is the expression for force here, students? So here F equals BIL sine theta. So substituting, B is 1.5 into 8 into 1 into sine 30. Very well, sine 30 is half. Half and 8 goes 4 times. 1.4 into 4. So this is 0.6 Newton per meter. How is that? Force is Newton. But the question says per unit length. Magnetic force per unit length. So it is Newton per meter. So simple analysis of this statement will help us to solve the problem easily. Next one. Two long parallel straight wires. Problem on parallel straight conductors. Two long and parallel straight wires carrying currents 8 ampere and 5 ampere in the same direction are separated by a distance of 4 centimeter. So they are separated by a distance of 4 centimeter. Estimate the force on 10 centimeter section of the wire. Two long and parallel straight wires, A and B, carry currents 8 ampere and 5 ampere. So I1 is given to be 8 ampere. I2 is given to be 5 ampere in the same direction. They are separated by a distance of 4 centimeter. Distance of separation between them 4 into 10 power minus 2 meter. Estimate the force on 10 into 10 power minus 2 meter length of the wire. So, again by expression, F is mu naught by 4 pi 2 I1 I2 by D into L. So very clearly we have derived this. Now here it is not D square, it is D, or F is 10 power minus 7 into 2 into 8 into 5 minus 10 4 into 10 power minus, so here the 10 centimeter, 10 into 10 power minus 2. Again a very simple simplification. Simplification left to you all. So what does force turns out to be? So this is 2 into 10 power minus 5 Newton. So much is the force acting on that section of the wire. The last one, which we have already done. This is an assignment for you all. A square of side 10 centimeter consists of 20 turns. Number of turns is 20 and carries a current of 12 ampere. The coil is suspended vertically and normal to the plane, making an angle of 30 degrees with the direction, and the field strength is 0.8 Tesla. What is the torque experienced by the coil? What is the expression by torque? So torque tau is B I N A. B is given. I is 12 amps. N is 20. Square area can be calculated. So from this, somewhere tricky, theta has to be added. So what will be now? Yes, there is a component which is sin theta. Substitute, you will arrive at the answer. So students, we have solved sufficient problems from moving charges and magnetism. Next, I'll start with potential and capacitors. Go back to that session. Be familiar with the expressions. Come prepared. Until then, have a fine time. Thank you.